Let's dive into data analysis models, which can be considered the core software of data analysis. Before examining data analysis models, let's first understand what a model is. A model is defined as a representation of some aspect of the world based on simplified assumptions. In data analysis, a model mathematically describes phenomena for the purpose of representing the real world in a plausible, simplified form and is incorporated into computer software. To summarize, a data analysis model is a deterministic, predictable mathematical formula. For instance, a regression line that predicts expected sales based on the number of salespersons at each branch fits this definition. The deterministic part of the model doesn't perfectly represent the observed world. The difference between what the model predicts and what actually happens is known as residual error, the second component of the analysis model. In essence, a real-world data analysis model is about observed values, where the deterministic model might be something like y equals a multiplied by x add b. This formula is used to predict the world, but naturally, there will be differences between the actual values and predictions, which constitute the residual error. This error isn't about mistakes, but rather the unavoidable inaccuracy of the model in precisely representing our observations. Hence, we call it a deterministic model. A good analysis model, then, has minimal residual error. You can think of a data analysis model as a subway map. There are various real-world terrains where subways are installed. Depending on the designer, the subway map can be represented in different styles, like the underground map style, Harry Beck style, or Google's redesigned map style. The same data modeling the same reality can lead to different analysis models based on the analyst's skill and capability. Different models yield different analytical perspectives. Essentially, a model is a deterministic formula that predicts something, like a regression equation y equals a multiplied by x add b. There will always be real values that appear. There will always be a difference between predicted and actual values termed residual error. Due to the presence of residual error, not all models are the same. For example, weather data is universally shared, but forecasting differs from country to country because each uses different analysis models. In essence, it's the deterministic model plus residual error. Better models are needed for more effective predictions. Therefore, when comparing weather apps, we judge which one is more accurate based on the model with less residual error. We have just explored the concept of analysis models.